But here's where it gets controversial. The world is drowning in carbon dioxide, and scientists are racing to find a solution that doesn't rely on burning fossil fuels. A groundbreaking study from Harvard University has uncovered a radical idea. What if we could harness sunlight to actively remove CO2 from the atmosphere, turning it into a clean energy resource? This isn't just a scientific breakthrough, it's a game changer for the fight against climate change. The challenge lies in the sheer scale of emissions. Every year, humans pump more CO2 into the air than nature can absorb, driving global warming. But the stakes have never been higher. As climate crises intensify, researchers are scrambling to develop technologies that can both reduce emissions and extract CO2 from the atmosphere. Traditional methods, like direct air capture systems, are energy-heavy and costly, making them impractical for widespread use. Enter the photobase revolution. Harvard's team, led by Assistant Professor Richard Liu, has pioneered a method that uses sunlight to trap and release CO2 in a cycle. Unlike conventional solvents or sorbents that require heat to release captured carbon, this system relies entirely on light. The key innovation? They've designed organic molecules called fluorenyl photobases that act like tiny solar-powered filters. When exposed to sunlight, these molecules rapidly release hydroxide ions that bind to CO2 in the air, effectively trapping it. In the dark, the reaction reverses, releasing the CO2 and resetting the photobase to its original state. This is no small feat. The team tested a molecule called PBMEOH, which captures CO2 only in bright light, but achieves the highest efficiency when exposed to sunlight. Their results show that this system can operate continuously, with a mere 1% loss of efficiency per cycle, meaning it could run for decades without major maintenance. You could imagine replenishing it every 100 cycles, Liu explained. The implications are staggering. If this method scales, it could provide a low-cost, renewable way to remove CO2 from the atmosphere, offering a lifeline for industries and cities struggling to meet emissions targets. But the road to commercialization isn't without hurdles. Challenges remain, including optimizing the system's exposure to light and dark, and ensuring long-term stability. While the best solution is still under development, photochemical approaches offer a promising alternative to traditional carbon capture. Liu emphasizes that the urgency of the climate crisis means exploring new ways to remove CO2 is more critical than ever. We can't eliminate all sources in the short term, he notes. Carbon capture from the air and from point sources will be essential. So, is this the future of climate action? It's not a silver bullet, but it's a step closer to a sustainable solution. The question remains, will the world embrace this innovation, or will it fall victim to the same inertia that has kept fossil fuels at the center of our planet's woes?